Cool. And there we go. Hey, how's it going, man?
Good. How are you?
Pretty sweet. So I was looking at your videos. It looks like it doesn't quite home or auto home correctly at the beginning there. It was like touching the first point and then kind of moved to some crazy other place instead of going
Yeah.
to the second point correctly.
Yeah, that seems about it.
Sure. Let's just make sure everything's working correctly. If you go to the screen on the printer itself and just do the auto home function, let's make sure it homes correctly. That should be a good indication that the machine's working correctly at least.
All right.
Do you know where that function is? The auto home under prepare,
Yes.
right? Okay. Actually, is the machine presently at home?
He should be. Yes.
Okay, let's go ahead and turn it off for a second. The whole machine,
Okay.
just power it off.
All right. That's off.
And take the lid off, and then just move the head by hand away from home, kind of like into the middle of the place.
Okay.
Okay, and then yeah, that should be fine. If you don't mind getting your hands a little dirty, you can grab the threaded rod of the back there that raises the bed up and down, and just turn it a slight amount, just so it's up, just so it's
Okay.
not like on home at the bottom there.
Yeah, it's off the sensor now.
All right, cool. So let's go ahead and turn it back on, and then watch it click all three of those limit switches correctly.
All right. Do I need auto home now, or will it do it on its own?
Yep, that's what we're gonna do. So now
Okay.
that it's off of each of those, we'll auto home and make sure it does that correctly.
Auto home.
So the bed goes down. Is this coming to the left, or is it coming left and forward both at the same time?
Left and forward both.
Okay, that's the problem. All right, let's stop it.
Okay.
Okay. So something's not right here. So basically, when it goes diagonal like that, that's one of the motors, one of the axis motors. There's something wrong with that, or
Okay.
or like some physical thing. So turn it off.
All right.
So let's grab the head now, and I just want you to sort of like move it by hand, just left and right, and then forward back. How does that feel? Does it feel like? And I want you also to watch. Do you see those motors in the back corner of the machine? One on the left, one on the right.
Yes.
Yeah, I want you to watch. Make sure those turn as this moves around. Do those both look like they turn correctly?
Let me get a flashlight.
As you move the head around, those belts should turn those pulleys on them, right?
It looks like it. Actually, I think one of my belts is off the track.
Okay, cool. Yeah, let's go ahead and fix that up. Where's that? What's going on where?
It's on the left-hand side facing the printer. So it'll be that one in there.
So that's not on the pulley right there?
No, it's not on.
Oh, no. You got to restring a belt. That's a pain in the butt, bro. But I can help you with that. Okay,
Alrighty.
so what we're going to do is we're going to take the whole belt assembly off. It's not going to come off the head assembly. It's just going to come unstrung from these pulleys and these idlers. So you can start by, do you see the one on the left there, how it goes to the black bracket on the left there, right there? Yeah. So
Yes.
so go ahead and slide it off that far one first. That should be easy. And then you can take all of that off. Just completely unhook it from the back. Unhook it from that pulley, from that motor completely.
Okay. Now the pulley is lifted up. So.
The pulley's lifted up.
Yep.
Wait, it's not loose on the motor shaft though, right?
I've got it off, but it's like it's not loose. It's lifted up though.
Yeah, no, that's okay. One side will be high and the other side will be low.
Okay, yeah. But I got the belt off.
Okay, so go ahead and make and hang the belt forward of the rails. Just gather it there.
Like that.
Yeah, well, we're going to get all the belt off actually. So.
Oh, okay.
Yeah, so do the other side the same way and lift that off. And then what we're going to do is we're just going to hang the belt forward of the rails, unstrung to anything.
All right. It's hanging now.
Yeah, but your other belt is secure. Is that what you're saying? You don't want to the other?
Yeah, the other belt's on there pretty tight.
Okay, so the other belt we don't need to worry about that.
I don't think so.
Okay, that's fine, I guess. We could just do the one belt. There is two, and normally I'm just used to putting both of them up at the same time. The other one's fine, I suppose. Good.
Yeah, no, everything seems right. It's on the pulley like it should be.
Right. Okay. So basically, the way we start stringing up a given belt is that we start at the pulley on the motor. So the first thing is to go ahead and sort of put a loop in there and try to grab the pulley.
Okay.
Okay. So kind of pull that, and now the length that's between the pulley and the head at this point, you want to go ahead and pull that out and attach it to the back pulley on the far left end, right? Do you know what I'm talking about? Where you took it off initially?
Yeah, I've got it on there now.
Okay. No, pull it further to the left. Right?
Okay.
So pull that over those two knobs.
Oh, okay. I see what you're saying.
Right. All the way over. Now get the other piece that's there as well.
Over here?
No. Keep on the left side. That loop right there. Yep, grab that. And
Okay.
attach that. Pull that out and pull it to the left to attach it to the pulley that you
Oh,
have there.
okay.
Right.
Yeah, the other bearing.
That's step number 2. So step number 1 is the pulley on the motor, and step number 2 is right there. Get that?
Okay, and that's going to be smooth side to the bearing, correct?
Yes, correct.
Okay.
Pull the slack out of that. Pull your length on the far left and pull the slack out of all that so you have a nice.
All right. I think that's right.
Okay.
Oh, no, but split off the pulley again.
Okay, yeah. Keep it on the pulley, obviously.
Okay, there we go. Now it's on the pulley and on the bearing.
Yeah, so now you have a few more points to do. So now pull that back to the corner there. Get that on the looped the bearing in the corner there. Now do that one that you're at right there. That's the last one you do, not the second to last. So
you want
do that one there. Keep the one to your near left on there as well. Okay, right? So
okay. Now is that going to be the smooth side or ridge side?
The ridge side should be on there, I believe, right?
Okay. Yeah, that's what looks right. It was different.
Yeah. So that one that you just passed over just there in the corner, that's the last one. You got to basically open the door and kind of get your head in the machine looking up, and you can use your thumbs like leverage to sort of get that onto the last one there. You got to use both your thumbs basically.
All right. Let me set this down. All right. I think that's on there.
All right, let's go ahead and manually move the whole assembly around by hand again to sort of check that all those points look like they work correctly.
That's much tighter.
Okay, but I want you to look at the motors, right, with their pulleys. Do they rotate correctly? They're on there as they move everything around?
Yes.
Cool. And the points on the far left and the far right, those two, they look like they move around okay as you move?
One of them, the one I just put on, I think slipped off just a little.
Which one where?
That one there.
That one? Are we able to sort of nudge it up into place?
Yep, it's in place now.
Okay, cool. Now feel it again. Move it around by hand.
I think everything's fine like it should.
Okay, let's power it on and do auto home. Bring the bed up one more time before you do that. Notch the bed up a little bit.
Yeah.
All right. Let's go ahead and give it auto home and see if it auto homes correctly.
All right. Now the LCD screen, is it supposed to be just a quick press and it work, or sometimes it seems like I have to kind of hold it?
sometimes the it can seem a little sluggish. I mean, if it's an old unit, yeah, sure. So it went down, and now it's going straight to the left, correct?
Correct. Yes.
Okay, click, and then straight forward, correct?
Correct.
And then click.
That's
All right,
it.
that's a properly homing machine. So let's try your sample G code again and see if it correctly begins. Wait, first let's make sure that you're properly dual level. Do you know about that, what that's about?
I do not.
Okay, so basically during this auto leveling process, given that your machine is a dual head, it will touch the left head to the left rail and the right head to the right rail. So that's
Okay.
that's a 2-point leveling system. So that means that those two heads need to be properly dual level, and for the
Okay.
whole auto leveling to properly execute. With single heads, it's not an issue because they have a single point. It's the single head.
Yeah.
But with this, it's vital that this properly level. So let's go ahead, and what we're going to do is just use the manual control. You've auto leveled, it's already on. So basically, just another thing to keep aware of is when it goes on, it doesn't know where it is. So if you do auto home, now it knows that it's at 000. But if you don't do that, it has certain like fail safes in place. It doesn't want you to raise the bed up into the head and crash it. So
Yeah.
if you just turn it on and go into manual control and try to raise the Z up, it will restrict you to just raise up a couple millimeters.
Okay.
Unless you first unlock that by doing auto home, and then it's like, okay, now I know where I'm at. I'll let you go all the way to the top.
It's like a normal CNC then.
Yeah.
Like a mill. Okay.
Right. Yeah, those limit switches work the same way. So basically, your limit switches for the Z, there's one at the bottom, right? It's home is at the bottom, which is weird. Most printers home with the bed right up at the nozzle tip, not at the bottom like that. That's kind of inverted, but you know, it makes sense, obviously, because when the machine completes and homes, you want it to go to the bottom. You don't want it to raise the bed with your thing, you know, smash it up into the head. So it kind of makes sense here, right? So, and then the left axis, that limit switch is on your the head itself. If you want to see it, you can check it out. But we're going to dual level this right now. So what we're going to do is you've auto homed it. That means it'll let you raise it all the way up its full Z axis amount in the manual control. So let's go ahead and do that. Let's go to prepare.
Yep. There.
And then, go ahead and raise it all the way up. It should zero out at exactly coming shy of running in. But, you know, I always go to only like 4 at first, and then I kind of increment it because I have seen.
See, I noticed before I could go to it was +6 and it still wasn't touching the head.
Yeah.
Okay. Or -6. I'm sorry.
Right.
Yeah, I'm at 000. I've still got a pretty large gap.
Go further. As far as you can, just don't run it into there.
That's -6, and I've still got, you know.
Okay, that's fine. Just as close as you reasonably can. Now there's like some fancy G code that like automatically moves the head and stuff to where it exactly needs to be. But I think it's silly that you need to have it around to necessarily do this procedure. And you could just do it with these manual controls easily. So this is the procedure I recommend rather than use the fancy G code to have it go everywhere for you. So what we're going to do here is we're going to turn the machine off. Now, when the machine is off, the power to the stepper motors is out. When the machine is on, right, the way the stepper motors work, they're not like DC motors. It's not like you just give them some current and they turn. What they do is they have a current that they draw that locks them in place, and then they receive little pulses to increment their little steps.
Okay.
So when we turn the power off, they unlock and we can manually move things by hand. That's why.
All right, so turn it off.
Yeah.
All right.
What we want to do is we want to bring the head to the middle of the bed. Leave the bed up. We want to bring the head around to the middle of the bed.
All right.
Okay. So, well, forward. It's easy to work kind of forward, but it's certainly a better point in the very middle. You're right. Yeah. So what we're going to do is we're going to get a piece of paper or a business card or a Post-it. A Post-it works really great, actually, because of the sticky side. It lets you sort of stick it to your finger and just slide it around.
Okay. I think the best I've got's the receipt from this. All right.
So what you're going to do is use this Post-it like a feeler gauge between the bed and the nozzle tip on the left side. And then what you're going to do is grab the threaded rod with your thumb and forefinger and very carefully increment it up. So you close that gap. and then you're scraping with the paper to feel the scrape on the left, and you want it to match the scrape of the nozzle on the right.
Okay. All right, so I want it to feel tension, correct?
Are they both the same?
Yeah, they feel like it.
Okay, well, let's suppose they weren't and you need to adjust it, because it happens a lot, actually.
Yeah, no.
And it's important that it be properly adjusted. So the adjustment mechanism, the way it works, there's a screw that you turn, and based on the way that you turn it, the whole assembly pitches either clockwise or counterclockwise. The left nozzle remains at a fixed height, and either the right nozzle is pitched higher or lower to sort of match it, is the way that adjustment works. So the adjustment screw, if you look at the top of your hot end assembly, it's the only thing that's asymmetrical about it. There's a hole off to the right side.
Yep, correct, right there.
Yeah, right there. That's the adjustment hole. So you'll stick your Allen wrench down in there.
Just a moment. Do you know what size that is by chance?
It's one of the common ones, like 3 or 2.5.
All right, give me just a moment. Let me get them out of here. Oh, that's pretty far in there. I'll have to grab the actual wrenches. All I have is the bits there.
Yeah, no, it's okay. Yeah, those bit things aren't going to get down in there. You need an actual Allen wrench for sure.
Okay. All right, give me just a moment. I'll run and grab a set.
Sure, no problem. It's cool. Awesome. Excuse me, I have a cat on my workbench. He's kind of in the way.
Well, we just moved, and I'm trying to figure out, especially metric. I don't use those hardly ever.
Yeah.
Okay.
Excuse me, let me get this cat away from here. All right.
Oh no, you're good, man.
So is that the right size? Is that one sitting there correctly? You feel
it is.
The head there? So basically, yeah, go ahead and get that in there like that. You don't have to turn anything, just sit it in there. And then put your face down in there like you're looking at the leveling again. Okay. And as you turn it one way, notice which direction that pitches the head. If the secondary comes further or if you're putting it closer. Can you see that? You probably, if you can't see it, check it with the scrape of the paper. The scrape will become tighter or looser on the right side as you do that.
All right, I'm gonna switch down. Yeah, I can feel it tightening up. Seems like counterclockwise makes the left side tighter.
Right, so it's only the right side that's being affected when you turn that. The left side remains same. So what you're doing is you're using the left side as a reference to match the right side to it.
Okay.
I'm just noticing that my cat moved my camera earlier. There we go.
Now, what's the best way to clean the glass from was it wolf bite? I think is what it's called.
Yeah, a really great way to do that is to slide the bed out and then under running water, use a razor blade to just kind of shave it clean.
Okay. Does it matter whether it's cool or hot running water? Or?
No, not especially. Certainly what you don't want to do is put any kind of glass cleaner or any kind of contaminant on the bed, which would, not work well with the.
I didn't know if maybe like a Brillo pad or what exactly would be best.
Well, you don't want to texture it by scratching it, but little razor blade works like a squeegee quite well under running water.
Okay. All right, I think I've got them pretty close there to where it pulls and has a slight pressure going back.
So
on
they
both
match,
sides.
right?
Yeah.
Cool. Great. So a thing you want to be mindful of is as your printer does all its prints, at the beginning you see it do that brush wipe, right?
Yes.
So
Where it
that
goes
brush
across.
wipe, yeah, that brush wipe is going to repeatedly wear those brushes. So it may even be the case that you get kind of an uneven wear pattern, and now you're kind of not properly, dual aligned. Certainly, if you replace a worn nozzle and leave an older nozzle on the other side, you're going to have
Yeah,
a
yeah.
little bit of a difference there, and you'll want to adapt to that by doing that adjustment procedure again.
Okay. Now, my back left bed screw, I just noticed it's backed a good bit out compared to the front one. Is that
Yeah.
correct? Or?
Yeah, no, that's totally fine. That's
Okay.
exactly correct. You want there to be some slack on those. They don't want to be tight. The top surface of the bed should not be touching the underside of the screw head, because what those mechanisms do is they they push up on there and hold the bed in place.
Okay. Yeah, then that should be good then.
Sweet. So
All right.
let's go ahead. We can run our test G code again. We can turn
All
it on.
right.
Of course, the lid's kind of in the way.
Yeah.
There we go.
Is the lid necessary with anything, that's fairly low heat?
It's necessary with the only time we take it off generally is when we print with PLA.
Okay.
Are you printing with PLA or ABS at the moment?
It'll be PLA right now.
Okay, and you properly sliced it for PLA, and you have the PLA wolf bite on there, right?
Now I've got my program that I made off of Fusion 360 is. The other one I think is for the ABS. I was just trying to get it to run in general, the test program.
Mm-hmm. Well, if you want it to run at its optimum design state, it generally runs best with ABS, actually, because the Wolfbite product, what it does is it's heat activated, so it becomes
Okay.
hot at a given temperature and sticky to heat activated glue. And then
Okay.
when it's cool, it's not sticky at all. So essentially,
Yeah.
while the bed is hot, the print is glued down to the bed, and then it's designed such that it becomes unsticky at a particular temperature, because what you don't want is for it to cool completely down and be still stuck on there, because what happens is as it cools, the print kind of bows, it flexes a little bit, and you can
Okay.
actually stress the glass. If the print remains stuck while it's completely cooled down, you can actually stress the glass such that it breaks the glass. It looks like somebody
Okay.
took like a chisel and chips a piece out of the glass.
All right.
So
So I need to take the print off before it cools all the way then.
yeah, so basically what you want is to just sort of walk up to the printer after it's finished and been allowed to cool down. If you just turn a printer off and let it manually, just sort of normally cool down, that's
Yeah.
fine. It's not like, it's a pretty strong glass, so it's obviously not a good idea to just put it in the fridge to try to rapid cool it.
Yeah. Yeah.
But yeah.
Okay. So auto home first before I start the program, correct?
The program contains an auto home at the beginning of its code anyway. It's fine.
Okay. All right. It'll take a minute. It's cooled down now from before.
Oh yeah, sure. That bed takes its sweet time to heat up, huh?
Oh yeah.
So this Axiom machine is the 4th generation product of Airwolf, and the one you see behind me right here is the 5th generation. This is called the Evo.
Yeah.
And it has the head and the bed, but it also has a third device. It has a chamber heater to keep the chamber heated. Because so
That's
the reason why an enclosed chamber design is so crucial for a good printer is because as the printer prints, the layers near the bed, they remain quite hot, and then the layers remain quite hot near the head as it prints. But when you print at a critical height and there becomes this cool band of material in the middle that's cooler than, say, the topper and the bottom sections,
Yeah.
those temperature differences start causing your print to, like, its layers to separate and peel apart.
Okay.
So that usually happens at about like an inch up if it's not properly like contained and everything. So the chamber heat of the bed actually is critical. I believe
Okay.
in I believe in the large settings default profile for Apex, there's a specific understanding that large means like you're filling the max height of the thing.
Yeah.
So what it does is it has an automated command at a particular height where it's going to actually increase the temperature of the bed to maintain the chamber temperature and make sure it prevents like those tall item
Okay.
splittings.
Now that's really important with like polycarbonate, correct? Or
Oh yeah, absolutely. It's critical for polycarbonate. It's definitely, I believe the polycarbonate profiles include that feature at other defaults as well, and to a greater degree. If you
okay,
watch
so
your, yeah,
that's my final goal is to be able to print polycarbonate. That's why I bought a very expensive machine to start with.
yeah, absolutely. That hot end can get upwards of 300 degrees. It's all the thing that's like most of it's off the shelf components, right? The main board, the front screen, all these motors. But where the
Mm-hmm.
most invested, time in the design is definitely in the hot end. You see those tan pieces above those. Those are to make sure though the blocks don't transfer heat up the barrel
Okay.
and cause the filament to swell.
All right.
And then,
How often do I need to grease the rod in the back and the threaded rod? Is
I
that
mean, not so often. I've operated machines for like a long time without doing it.
okay?
But yeah, no, it's a worthy consumable to keep on hand. White lithium
Okay.
for sure. Yeah.
Now is that just standard? I think it was 8 millimeter threaded rod, or is it anything special?
It is a metric threaded rod, yeah.
Okay.
Because all the units in the slicer software are also metric. Oh my goodness, man. I worked on a printer one time where the design was such that the threaded rod was not metric, and
Oh
yet
yeah.
the slicer software increment layers were.
Yeah.
So like a single layer wouldn't be 0.1 millimeter in the slicer software. It would be specified out to like 6 significant digits, and then you do multiples of that as your layer height. It's like, come on, man, that's ridiculous.
Yeah. I'm a machinist by day, so that's normally metric is like my mortal enemy. So it's kind of strange going from standard to all that stuff.
Yeah.
But, so it should when I'm making a print on Fusion 360 and transferring over to Apex, will it automatically put in the cornering and the cleaning uh, code
Yeah,
or the
presumably,
leveling?
as long as your Apex software is set up correctly. I can have you open up on your computer and check that out for you to verify
Yeah,
that.
I've got that sitting here to the side just in case. Okay, so and I just put it on the X, expert or other mode.
Yeah, we always want to be in basic mode. So basically, the thing is, there's so many settings that you want to start in basic mode because it'll set this and that correctly for you, and then you can open up the advanced and modify little features. A really bad way to operate is to remain in advanced mode and just specify everything, because
Yeah,
really a lot of time goes invested into making sure all these profiles are perfect for you. And honestly, in my opinion, it's like 80% of the value of the brand all on its own is that time. Because like
yeah,
if you had some other printer and it had some third party slicer software, you'd be in the same place as just operating in advanced mode here. But it's really important to take advantage of these basic.
so I thought that was really cool. Is you just kind of plug in your material and the quality you want. It
Yeah.
just does it.
So at the top, we want to I believe you're looking. Let's look at. Sorry, printer. What do you have? Machine. Let's click machine. Axiom Dual Direct Drive. So that's confirmed. So if you had some other Airwolf product, you could add new machine and then you could switch between the printers that you had. But this is the correct one. So that's good. So you got the material, right? So you
No,
see
gender feel
um sorry, someone's trying to call me. I just
No, you're fine.
so you see the materials there, right? Let's go
Yeah,
pull out the material list again for a second.
yeah,
So what you see is basically 3 formats in here. You see single words, which is just that's the material for that. Then you see also word with dual color, okay? And then you also see blank with blank. So all those single ones, those are pretty self-explanatory. Both heads will print that material. A single head will print that material. those are all single material profiles, those single word ones. And you can
Okay.
assign them to primary or secondary head. Like if you want to, you can print all your ABS in your left head and print all your PC in the right head, and sort of keep those consumables separate. And
Okay.
like you could do something like that. You see where it says nozzle primary? So you can select nozzle secondary here to have your other, and then switch to your other material, right? You could do like
Okay.
that.
So I pick secondary and just change the filament to whatever else I have.
Yeah, yeah.
And if I switch back, it'll switch to.
So this profile, ABS with hydrofill, this is necessarily a profile where your material that you're printing in prints in the primary head, and then that secondary width, that's the support material. It's a completely other material with completely different settings. It'll print
Okay.
in the secondary head.
Okay. So if I want one head, like say polycarbonate with was it hips or call it PLA? So that would automatically do my first left nozzle PC and then the right nozzle PLA, or
Yeah, and that's specifically for a print where you're using both of those materials at the same time.
okay.
Right? You don't do that if you're just delegating one head one and one the other. In that
Okay.
instance, you do the single material and then specify the head.
Okay. Now, can you print two different materials onto one print?
Yeah, absolutely. Those go to blank with blank. Those are like specialized profiles that are key to help you do exactly that. Now,
Okay.
the reason why there's no PC with hydrofill, so hydrofill is a water soluble material
Mm-hmm.
that will dissolve away with water. Sometimes you have to agitate it a little bit, but generally it washes away like a
Okay.
thick slime. And the reason why you don't have that with PC is because PC prints up into 300 degrees. And the fact is, when you put extruded PC onto the hardened hydrofill support structure, it just melts the support structure because that
Yeah.
hydrofill operates at such a lower temperature and much
Okay.
closer to ABS. And the ABS hydrofill temperature profiles are like, spot on, and generally the thing that they update with all the
Yeah.
updates. So
I think I have some of the hydrofill on back order actually, or I
that's
may have got it.
Yeah, that stuff's expensive. I would urge you to do a little test before you make sure your big long 5 hour plus print you want to try,
Oh yeah.
whatever it is, works correctly for you.
No, everything for a while is gonna be short and trying to make sure I get everything right. So.
Mm-hmm. Sweet. So the other settings on there, right? You see what those all are. The quality, right? That's basically a layer height. So if you under quality, if you choose a one up to the top here, those are going to give you the thickest, fattest layers, and the one
Okay.
at the bottom of the list, those are going to give you the thinnest, finest layers. So the more layers you do, the greater resolution you have, but also the longer print time it takes.
Now, does that give you a stronger print? The thicker the layer or smaller the layer?
Well, you also have to consider like geometries as well. So if you were to print a sphere sitting on the bed there, well, first of all, you
Mm-hmm.
probably intersected a few, millimeters down in there, so it had a flat bottom on it and not a single point, right? But
Yeah.
I can show you how to do that in a second. But you put the sphere down, and as you notice, as it prints underneath the sphere, it kind of looks messy, and then as the angle turns more to a 90-degree angle, the bottom of the sphere gets cleaner and cleaner and cleaner. And of course, the whole top of the sphere is completely clean as it stacks those. But the underside of the sphere,
Yeah.
the angle could be an issue. So basically, what you want to understand is the thickness of your layer depends on it. It restricts how, like, what kind of angle you can effectively print.
Okay.
So if you have things at like a greater than 45-degree angle on the bed that are like this, then what you want to
Yeah.
do is select those finer layers. So you can, because a given layer, right, is offset with the layer above it to sort of do that. And if the layers are
Okay.
thicker, it's a more, a more offset. But if they're thinner, they can more gradually offset. So
Okay.
yeah. So that's what the quality is about. It's the layer height. And then the nozzle, obviously self-explanatory. The nozzle size there, you can actually
Yeah.
attach different nozzles. If you open that up, you can go all the way up to 0.8. So basically, if you imagine what the nozzle is, that affects what your tolerances are on like an XY plane. So a given line that you draw down has
Yeah.
this width, right? Obviously.
Yeah.
So, the width of the line essentially is an encroachment on your tolerance, right? This line is your model, my finger, but this
Yeah.
width, it's like if you draw with a pencil, but then you go over the thing with a thick Sharpie, right?
Okay. Yeah.
So the thinner your line, the better your tolerances are on that XY plane if you want to work with smaller nozzles. But if you're working with a giant thing that you want to make a huge part, you'll want to get that 0.8 nozzle on there so you can move more
Okay.
material through at once.
Now it's starting to do something now.
Sure. So it's homing at the beginning of its code. That goes to the bottom.
Okay.
This comes to the left and then forward. Click, click, and click.
It says heating again. It seems like it standardly heats both nozzles. Is that pretty
Yeah.
normal, or do I need both nozzles heated normally?
No, you don't need both nozzles. The reason why it heats both is because when it heats, it expands and it wants to equally expand both to use both for the leveling correctly.
Okay. Okay. That makes sense.
But after it does the leveling procedure, you will see the secondary head cool down.
Okay. That makes more sense. I didn't know why it was doing both. Even on, the drawing I'd done it,
Mhm.
I didn't even touch the secondary nozzle and it started heating up, so I didn't know.
So also, obviously, you want to make sure that dual is properly adjusted. Some temptation people have is, hey, I'm going to dual adjust it such that I raise the secondary nozzle completely out of the way. So it's you don't want to do that because then it's not going to auto level correctly, right?
Yeah.
The both heads need to be down correctly or properly auto level.
Now, is it tilting the head, or is it just pushing the right nozzle up and down?
It tilts the whole head assembly and pitches the right one higher or lower. So the left
Okay.
one remains fixed, and you're just raising or lowering it.
Okay.
Yo, this cat needs to stop rubbing his face on my camera. Buddy, come on. Come on. Get out of here. Get out of here. Do. So that hot end is almost done, huh?
It's 251 on the primary and 186 on the secondary.
Uh-huh.
So the third number there, would that be for like a heated chamber, or?
Oh, where it says 3?
Yeah.
Well, actually, obviously, no. This model doesn't have heated chamber ability. That's just that off the screen component, off the shelf screen component that's in there. It's
Yeah.
able to accommodate designs that have up to 3 devices like that. But this particular
Okay.
model, it would never have anything there.
So there's machines out there with 3 nozzles?
Sure, yeah. There's machines with 3 nozzles. That's a thing.
Okay.
It's kind of weird. The thing is, with the single nozzle, the nozzle's in the middle there, and it can go all the way to the left, all the way to the right. With the dual nozzle design, the left nozzle can only travel as far over to the right as is allowed before the right. It doesn't want to run the right nozzle into the bed, right?
Yeah.
So it's actually restricted in its ability to move to the right by the width of the nozzle there. So
Yeah.
these dual machines necessarily have a reduced printing width compared with the maximum width, right? Compared with the
Okay.
single head designs.
All right. Now it's heated up to, I guess it's leveling out.
Sweet. So it's going to do its touching. Now it's important that it touch each corner briefly and, just for a moment. It's going to do its
Okay.
wipe first. So
Let's
wipey
clean the
wipe.
brushes.
Yep.
See, I haven't done that one yet, so.
Oh, okay. Right. Because it wasn't able to move correctly.
Yeah, I guess it was trying to go that direction. It just never made it.
Yeah.
Now I saw somebody commenting that they took the brushes out. Is that something that's suggested, or I
I
guess
mean,
it's actual?
if you're diligent about grabbing little boogers off as it starts, you can get away with that. Yeah, for sure. Some people like to do that because it extends the life of their nozzles because they don't want to brush them and abrade them all the time that way.
Now, does it extend it very much, or is it just one of those things that's in theory it helps?
Well, as long as you have the newer nozzle design, which it looks like you do, those ones are made of the harder aluminum and they last way longer. But they do
Okay.
eventually wear, and you do want to be mindful of that. So touch, doop, doop. Yep.
Now, is it supposed to touch the glass or the metal clip?
The metal plate. That's what it's doing. So the left touched on the left, the right's going to touch on the right, right? That's why it's important for us to be properly dual
Okay.
level here. So the right touches over there on that side too, and then the left's going to go all the way to the left and do that one over there. So this builds a 3D map of like it understands which corners of the bed are higher than which other ones. And it applies now this like corrective adjustment such that it's going to turn the Z rod and increment it or decrement it as appropriate to make sure the nozzle's equidistant from the bed everywhere it goes.
Okay.
So that's what that whole procedure does. And it readjusts, with each print. So we probably wanted to manually extrude before, make sure this stuff was coming out.
Yeah, it's on its way now. I could see it coming in, and that's fine as long as I know that it's
Yeah, it's going to do the skirt first.
There.
That's why the skirt is a thing, to make sure that starts correctly before it even begins the object. Do I see skirt material? Yeah, I do.
Yep, it's coming out now.
Super cool. Yeah, so the only thing like going forward is, I would say your dual adjust is a thing that you should check perhaps maybe every 2 weeks, just look at it. Like you might even look at it and scrape it and it's already fine. It needs no adjustment. That was it. That's all you need to do.
Okay.
Right.
Now, is it better to use paper or a feeler gauge? I saw some debate on that also.
Honestly, the thickness of the thing in question is arbitrary because you could turn your bed as you do that manual adjust to accommodate the thickness of anything you wanted to put in there, right?
Okay. So as long as you got the right feel to it, then it should be.
Yeah, as long as they just match each other, right? Yeah, you could put a whole book in there if you wanted.
All right. Well, I'm really excited now. It took way too long to get this thing, and it's finally printing.
Yeah. So another thing with the wolf bite, do you have multiple wolf bites? Because there's different wolf bites for different material, right?
Yeah. I bought the grab bag and PLA starter kit and the engineering starter kit, so I've got like 6 things of wolf bite.
Sweet. Yeah. So basically they have different activate temperatures at which they're sticky, and they have different release temperatures at which they release. So certainly you want to consider them contaminants of one another. You don't want to use the same brush between the bottles. And when you change your wolf bite, you certainly want to clean off all the old wolf bite. You can always apply the same wolf bite over the same wolf bite again if you just want to put more on there. That's completely fine. But
how long does it stay on the plate?
Well,
like if I put it on the night before, would it be fine the next day? Or
yeah, you want to hear something crazy actually that I just discovered? This printer that I got going behind me right now, this Evo, I'm printing medical supplies on it for donation. And there's 2 face shield files on the bed at a time, and it prints in like 2.5 hours. So I'm turning it over like 5 times a day at least. But I have printed now 120, so that's 60 prints on a single application of wolf bite, and it's still good.
Really?
Yeah.
So that's not something you need to really worry about changing too terribly often unless you change material.
Oh yeah, unless you change material. But certainly, it's worthwhile sometimes if you're really invested in a particular print, like maybe this print's going to be like a 60-hour print and it just absolutely has to stick down. So yeah,
touch your eyes and cross your T's.
Yeah.
Okay. Well, I think that's good. I appreciate it, man. That's awesome.
Sure. No problem, man. Absolutely.
All right. Well, if I have any other problems, I'll probably message you, but hopefully I won't.
Sure. Sweet. And obviously, just again, the ideal way to operate it is with the SD card, making G-code files from Apex there. And oh my goodness, that freaking super fancy, what is it? The AstroPrint function. Man, I hate that thing.
Now, I did have one other question. The people who sent it to me, they sent me an old thing of PLA, and it's very, very brittle. Is that trash, or is there a way to recondition it? Or
yeah, no, if you can break it by hand easily and it just snaps, that's not going to work for you.
Okay, I didn't know if there was a way to. I know you don't want to hydrate it, but I don't know, heat it up or whatever. But that's fine.
Yeah, basically the only hazard is as it feeds, it's just going to break the filament all the time. You may have to like pause and try to reload it if you can, but no, that's not.
Yeah, I noticed it wouldn't feed into the machine without breaking, so I figured something was probably wrong.
Yeah, and with PLA, you operate it with a top off. That's the only regular time you operate with top off is with PLA.
Okay. All right. Well, I appreciate it. And like I said, if there's anything else, I'll let you know.
Cool. Thanks. Have a good day, man.
Thank you, man. You too. Appreciate it.
Bye-bye.